Calculus, finding the volume using integrals. Set up the integral needed to find the volume of the solid obtained by rotating around the region enclosed. This is the problem that we'll need to graph in order to get our solution later. Since we're going about the x-axis, we'll need to have x on one side. These steps will show us how to get the points that we'll need to graph. We'll need to FOIL y minus 1 squared, and then also FOIL through the negative. This will change our signs and ultimately eliminate the 1's. This will leave us with negative y squared plus 2y. Since there's a y in both of these, we can take it out, and we'll also need to take out the front negative. This will leave us with negative y minus 2, which shows us that y equals 0 and 2. Now we can draw our graph. Since we found the points 0 and 2, we know the graph will only go to 2. We'll need to plot this point on the y-axis. Do not plot on the x-axis. It's y equals 0 and 2. Then we'll need to draw a circular arrow in the x-axis showing where it's rotating. Next, we draw our actual graph. Since it's squared, it's a parabola, but y makes it sideways, and the negative makes it turn into the axis. We'll need to draw a rectangular parallel to the axis which we're rotating, which is here, the x-axis. Now we have our formula, 2y integral y, f of y dy. We'll need to put in 0 and 2 on our integral, and then we'll need to keep y the same and put in our original function, which is 1 minus y minus 1 squared dy. Now we have successfully set up our integral. Volumes of cylinders. Find the volume of the solid obtained by rotating the region bounded. This is the formula we'll use for our graph. Since it says x is greater than or equal to 0, we know that we won't have to graph in the negative region. Y equals x to the third and y equals x intersects at point 1, 1. So we can draw our graph to have points 1, 1 in the positive region. We can also put a point at 1, 1 so we know where each of the lines are going to intersect each other. We'll start off by drawing y equals x, which is a straight line through the origin to the point. Then we'll draw y equals x to the third, which will also intersect at point 1, 1. We are going to reflect the graph over the x-axis. Since this is volume, we are going to draw a cylinder. Inside this cylinder, there is going to be a disk. This disk is what we're going to use to find the volume. We will use the formula pi times the integral of the outer radius squared minus the inner radius squared. Since the graph goes to 1, we know that our integral will go from 0 to 1. Our outer radius will be x, and our inner radius will be x cubed. Since we have the squares on the outside, we'll have to distribute in, leaving us with x squared minus x to the 6th. Then we'll have to integrate, which means we will have 1/3 x cubed minus 1/7 x to the 7th. Now we'll have to solve for the volume. By doing this, we must take the outer radius minus the inner radius. So we'll put 1 in for x for the first part and 0 in for x for the second part. This will leave us with pi times 1/3 minus 1/7 minus 0. This will equal pi times 7 over 21 minus 3 over 21 because we have to find a common denominator. Then we'll have 4 over 21 times pi. We must distribute the pi in, leaving the volume of our cylinder problem 4 pi over 21.